Alright, so for today I wanted to explain pointers. Obviously I saw, a popular thing to do, honestly. And yeah, I mean, if you'll find this one useful, don't forget to let me know, like this, please. So yeah, basically pointers, right? I'll try to explain it in the way that I started to understand it, and we'll see if it makes sense for everyone, because I think that's a really good way to get a grasp on it, right? Like, you don't have to think of the pointers as something that's magic, but you'll see. So yeah, let's get into it, right? So I guess first of all, if you don't know already, like pointers, let's do a hello world program, right? So printf, let's do the hello world. Okay, and the drill, and then main. So yeah, whatever, this is like hello world. So yeah, usually when we have variables and stuff, there are gonna be stuff like x is equal to something, right? It's just a simple variable, and we can print it. Sure, it's just like that. And this variable represents just a simple number, so it's just an int. So if you look at the memory where it's stored, it's gonna be something like I think, because it's little endian, it's gonna be in the reverse order, or at least it's gonna be something like 0 0 x 0, right? Then another one, and then a 1 and a 0. I mean, just how it's stored. But for simplicity, let's imagine that it's gonna be stored just like its order, right? Let's imagine that this is how it looks like in bytes, because an int is 4 bytes. So I mean, usually, I guess, if you use a long, then it's 8. But yeah, an int is gonna be stored just like this, right? Now let's imagine that we have another variable which is equal to x, right? So this one is still gonna be the same thing, but now if you modify y, I guess, what do you think is gonna get printed? Like, does x also change, or is only y gonna change, right? So well, I guess I should also print y. Okay, and yeah, you can see that only y changes. And the question, I guess, why is that, and how can we make that when we change y, x is also gonna change? And I guess the answer to that is that here we just copy this value exactly, right? I mean, that's what we see, and that's what we assign to. So x and y are two separate things in our memory. But as I said, we'd like to them to represent the same thing, and that's how you do it with addressing, right? But you need to use these special symbols, like, but I mean, the compiler helps you, right? So you have to put a star here, and also a star here to read the reference, and another one here, obviously, right? So that's how we make y refer to x. Now, this looks really like magic, right? Like, how does it happen? So if we run this, we should get 2 and 2. Right, so now x and y represent the same thing, right? Because we use this symbol here. But again, this notation here, so represents again just a single number. So if we take a look at how y looks like, right, it's gonna be some kind of number here. So it's still gonna be some I don't know, number. Let's imagine that this is the number from there, like in hex, right? So well, that means that we could actually just use something like long int then, I think, but you have to cast it, right? And we can just print it. I don't remember how the formatting is for longs, so ld, so you can actually just see what value is there, right? So it's this number. Like we can interpret a pointer just as a single number, right? But you know, maybe the question now is, what does this number represent? And I guess if you think of pointers just as numbers, it's easier to understand them. And probably the hardest thing actually is not necessarily like what is a pointer, because you know, the easiest answer is a pointer is just a single number. But maybe the hardest thing is what happens when you dereference a pointer, right? So yeah, let's say we have this long int, right? And then we have, I mean, at this point you can actually just do char pointer y. Let's do, like, you can actually just convert it to another kind of pointer, right? And now if we print z, even though it's not the same type, I think, you know, it's gonna print something completely random. But if we do int, we convert it back. Actually I had to, okay, let's use, right, it's gonna show us the same number because, you know, we print it as an int. But if, I mean, you know, if we do something like this, it's still gonna change both of them. So yeah, okay, so let's look now at an example of how to actually try to figure out what the pointers actually are. So usually we have a memory, right? And like nowadays it's gonna have like 24, like it's gonna be like something like 8 gigabytes, right? This big. But for us, let's use, like, I don't know, only 8,000 elements. So this will represent our memory, right? And we have these two functions, malloc and free. Well, there's also realloc, but that's just malloc and free, so it's not that interesting. And you know, maybe you saw something like x is equal to malloc, and then you use something like, okay, allocate 4 bytes or something. Well, I mean, for malloc we need stdlib. But yeah, maybe you saw this kind of call, right? And thought to yourself, well, what does this thing do? Well, if we do the same thing as we did before, it's just gonna return us a number, right? So if we print the two numbers, well, I have to cast it, so, and this one is an LD, right? So in the first case, here we allocate an int, right? And since we have the star, we say that okay, it's some memory, some location in memory where we have a number, right? And here we dereference it. But if you cast it to a long int, you can actually see what address was allocated, like where that thing was allocated. And again, it's just a single number. And like the magic, if you want to call it like that, happens only when you dereference that thing. So it's not like there's nothing special about the pointer. It's just a single number, and it represents an index in our memory array. Now, you know, it's pretty huge because we have a lot of memory, like in gigabytes. I'm really curious, like if you divide this thing by that once. Oh, I made a mistake. Well, actually it looks like it's like what, K M, maybe I'm missing something, like one number over the scale, but it's, you know, pretty big number nonetheless, because, you know, we have there's also the virtual memory, right? There's which maps the physical memory. So, but you can think of it as an index in a really big array, right? And basically that's what y is in this case. And when you dereference this array, it's just like saying, so maybe here, let's say that when you do like pointer x, or you dereference x, is just like saying memory of y, for example, right? I mean, even though there are different locations, that's how you can think of it. It's just like a shorthand for accessing in the memory array. And I guess a really good exercise to try and do for better understanding, you know, the pointers and stuff, is to implement your own malloc. So you know, and use this as a buffer. So it would be something like malloc, or I guess my malloc, let's not. It's gonna take in a size, so the size, and it's gonna return you an index in this array. So that's what you would have to, you know, implement, right? So yeah, I guess it's also up to you to think of how to store all of this, but, you know, implementing your own allocator is the easiest way to do it. And if you implement only malloc, it's gonna be really simple, because all you have to do is find the first place that is free in the memory and just add size to it, and, you know, you mark that as taken, and you return that index. So first is gonna be 0, then it's gonna be, I guess you can also have like head, right? Maybe like start is equal to head, and plus equal to size, and then return start, right? This is how like malloc would work in our memory buffer. So, but here you can see that we just return a number, because, you know, as you saw here, that's what we actually get back in a way, like it's just a single number. It only changes its properties when you actually use the pointer. But yeah, now let's try to use my malloc. So let's say that we have a is going to be equal to my malloc, and we want to allocate again 4, right? So it's going to be an int. Okay, and now the thing is, a is going to be a pointer for us, but you know, we don't have the star because you know, implementing it ourselves change the stuff a bit. So if we were to show a, let's only show a. Okay, I mean, let's keep that because why not? It's going to show us 0. And maybe that's the confusing part. Right now 0 represents the address, right? So it's not the value that we have in the memory, it's actually the address where we want to do something. So it's like the index basically. So you know, if we call it index, maybe it's easier to see that. So now we can actually do something like memory index is equal to, I don't know, 45. I think it's a letter. So we can write in that memory. We can even write at index plus 5, and in C, this is what causes segmentation faults, right? When you, because we only allocated 4, and now we write to a place in memory where we don't have access. But you know, with this approach you can do it because we already allocated the entire buffer. But in normal C you cannot really do that. Well, actually, I mean, you can, but it's not always going to work. So even for this one, if you do index minus 10, it's obviously not going to work. But again, you can just write to this thing like this. But now how do you do, you know, dereference? So for x we were able to do pointer x to access the memory. So here we only print the index, right? So again it's 0. But how can we take the value from there? Well, I guess the easiest way to do that would be, you know, char first byte is memory index. Like, this is the easiest way. But maybe we want to take all 4 at once, right? That's more of how it goes. So number, right? And we can say memory plus index in this one, but it's going to complain that, well, number should be a pointer, and I mean, this one doesn't really matter that much. I guess it's just an easier way to take all of them, but probably the way to do it for us would be memory index, and we would have to shift it to the left 24, I think, I'm not sure. Index plus 1, shift it 16. Index plus 2, and we shift it with 8. And again, I mean, you know, I'm not gonna do like little endian or anything, it's gonna be just like that. So now if we also print the number, you can see that this is the value that's inside that number. I know it looks pretty scuffed because let's do something like a smaller number, like 1. here I need to do +3. So it's gonna be 1, right? So basically, yeah, if you think about it, so let's do like a comparison. Right, and how manual, let's say malloc, so x and the reference for x, and I mean to show the value of a pointer you use p for formatting, but it's doesn't really matter. But yeah, basically this is, well, I guess maybe even better. Maybe even better is to do it like this. Oh, but I cannot. Let's say number x. Right. So in the the malloc way, we can just allocate the memory like this, and for us it's the same thing, like using the mymalloc function, and in both cases we'll get back an index, right? Now this is a bit different because it's marked as a pointer, so, and this star here is more or less a thing for the developer, I guess, to know that this is an address and not just a simple number, although we just saw that it's just a simple number, but it's a way to show you that, well, you can interpret it in a different way. But this is also the case, like if you think about it as an index, then you can use it as an index, the same way as here. Then to set some value inside of this pointer, right, we just access the memory at that index and we change it, and this is the exact same thing that happens here, but it's a bit more hidden from us what really happens. But what happens in fact is this, right? We access the memory array at location x and we assign a 1 there. So basically this thing, right? And then when we dereference, we access the memory at that location and we take the value. And I guess the type here is only used to know how much of the memory you access at once. So for an int we access 4 bytes in all cases. If we used a char, so char, well, I guess char index, and we use only 1, then we can do stuff like memory char index is equal to 45, let's say, or something. I guess 69, let's use 69, why not? And then we can have a char, the char memory at index, right? Well, I guess char index. And if we print this one, is gonna be another index, and for the char we can actually just print the character. Here, when we allocate the memory, we have to specify basically the size, so this 4, and we did it everywhere, right? Regardless of if it was malloc or our implementation of malloc. Then when we assign a value to a pointer, we have to dereference it, and that's just doing this thing, just indexing into the memory array. and depending on whatever size you used, or I guess more or less the type, it's gonna know how to do that automatically. So in the manual case, since we don't know what type index refers to, we just know it's 4 bytes, we do it like this. But for in pointer, it knows how to do this automatically with the memory. And I guess for character, since it's only 1 byte, it's gonna use it like this. But yeah, I mean, if you like, the best way for me to start to get a better grasp on pointers was to think of them as just numbers and not really think of what they refer to, unless I was dereferencing them. Like here, okay, I just assign 1 to some memory, like I don't really care about that. But like this thing is just a single index, as this is. So yeah. And sure, we can even allocate more memory in our own memory buffer, so that's one thing. But the other cool thing would be to actually free that memory, and I actually have something like that, if I remember correctly, done. It's like the custom memory allocator, and I think that's a worth thing to implement, custom memory allocator in C, because you'll learn how to handle this thing. Right, I guess hopefully it makes more sense if you think about the pointers as just numbers. At least that's how I got better understanding on it. And also another project that I think is really good for learning pointers is building a really simple compiler, but not necessarily like interpreter. Like you have to make sure that you actually compile everything to assembly, and you also need something that allocates memory. So maybe the best kind of language to do is something garbage collected, although that's pretty hard. I think that's a good thing. And honestly, if I think about it, like doing that, the garbage collector for a compiler is just implementing this memory allocator. And I have the memory allocator implemented in ds.h. So the allocator. So I would really recommend to implement an allocator, and all you have to do is have a function for allocating memory and a function for freeing memory. And yeah, you can use whatever types you want, it's not really important, but you're also gonna practice a bit like linked lists, because that's what you should use for storing the information about the allocator. Linked lists, it's the easiest way to do it. But yeah, in my case, it looks a bit weird because the linked list that I used was I mean, this is how the linked list looks like, right? It has instead of using nodes, I used uint. So again, like the type really doesn't matter until you dereference it. So you can use whatever type you want, because pointers have the same size anyway, right? So they are just 8-byte numbers basically, but it only starts to matter when you dereference them. But yeah, like implementing the allocation and freeing, that's pretty important, because if you only allocate, you can see that it's extremely easy to implement something that only allocates. It just increases the starting position. But once you add in freeze, it becomes a bit difficult, because you know, you can free something from the beginning and you can go back to it and start overwriting stuff if you're not careful. So that's you know, pretty cool. But I guess that's gonna teach you more how the memory layout looks like, not necessarily how to use pointers. So yeah, maybe just practice more with pointers. That's the only thing I can say, because even if you are gonna implement the allocator, I'm just thinking right now, will you be able to really understand like why these things are used? Probably not. Like, I guess I guess, you know, you'll understand it when you need to. So I guess this is another good example of having a pointer, or like having two variables. So int a1 is something, and then having another variable that represents the same place, or I guess the same thing. So, you know, if you don't need this in your code, then you don't really need pointers. So maybe that's a good thing. Or the other place where you need pointers is if you, let's say, have a function that takes in number 1, number 2, and it somehow returns the result like this, right? Instead of returning it as a, like with return, right? But again, the thing that you send here is gonna be a number, and again, when you use dereference, it's just writing to the memory buffer. So, you know, the star from here just represents, okay, I'll know, like, it's an annotation. I know that I'm gonna get some kind of pointer in this function, so I can do this, which means that you can write to that memory. Or I guess, you know, the star here tells you that, oh, the type of sum is it's an index. It's not just but I mean, you know, it's an int, but you know, C doesn't really have you know, imagine well, I guess you have to do it like this. I don't really remember. So yeah, like imagine index thing, right? So, you know, thing, oh shit, thing is an index in the memory. So, you know, I can have, I don't know, another function which we are gonna imagine that it doesn't do anything. Put but index should get, you know, some kind of index and the int value. Let's imagine that we work only with ints. So let's say this is an index. So then put at index, you have the sum. Right, so it's like, oh, I can just put an index. This is the index, this is the value. So you can see how it starts to resemble this this thing, but you know, you have to ignore this part. Let's not look at it. So it's like, you know, we have an index the same way as we do here. We have the value, but you know, it's easier when you use pointers because you don't have to do each step manually. So maybe that's the reason for pointers, because you know, you can imagine that probably there is a way to find the start of the memory to index it like this. But yeah, well, and I guess the other thing which might be confusing is that you can do stuff like, I guess, pointer memory is equal to something, right? You can do stuff like this, and it's like, oh, but you know, I have this and I also have this, right? And yeah, I mean, this one is, I mean, it's basically the same thing, right? So if you do this kind of thing, is just like doing memory 0 is equal to a, because it's the first one. And if you do memory plus 1 equal to b, it's just like doing memory 1 is equal to b. Alright, so what we did here, and yeah, I guess another way to write this thing but with pointers, which you know I wanted to avoid, was I guess memory plus index is equal to int 1. So it's the same thing, I would say. Yeah, so this thing, you know, shorter way to write this, but you know, since I wanted to show it better, I think it's easier to visualize it like this, with index plus something. So yeah, I mean, no, thinking about it, probably it makes less sense now for you, which is actually funny. But I guess that's how pointers work, right? Like when you explaining pointers until I go insane, speedrun. But yeah, basically, you know, you just have to think of the pointers as numbers, not think of them as something special. And when you do this operation, when you dereference the pointer and assign something to it, you have to remember that it's just indexing in an array and you assign a value to it. And when you dereference it this way, when you do something is equal to, you know, the value from this index, it's just doing this stuff. You just take the value from the memory and move it to your own variable. So pretty much that's all for pointers, right? And when you have linked lists or other use cases, it's the exact same thing, but you know, it looks a bit different, maybe a bit strange, but it's always gonna be like, when you dereference, you just access the memory array with the index, which is x. So you know, that's all that happens behind the scenes when you put the star. You know, and I guess, sure, when you have like a variable like is equal to something, and then you do pointer e is equal to the address of d again, I mean, it's kind of the same thing, but now imagine that like memory at address e is equal to d basically, or I guess I should use this. Okay, so if you look at e as an index and you index it into memory, then you have the same thing as d. But I guess it's, well, yeah, because if then you change e, the value d is also going to change. But again, e here is just an index in the memory buffer, and d is only a value. And yeah, you have to use this AND operator to take the address of d, so it's like this index here. But yeah, I mean, hopefully it makes more sense. Like, that's what helped me a lot, thinking of the pointers as indices or numbers, and implementing my own allocator when I had that homework like a couple of years ago. So yeah, I really recommend doing a custom allocator. You can find really good information, but I mean, optimizing the allocator, not really important. I think it's more important to get it to work and display, like implement an allocate, free, and like a dump to display the entire memory. And you have to play a bit around with it until you start to really understand how it works. And yeah, the other way to do it is to compile something to assembly. Like, even if you do brainfuck or something really simple, it also helps. But yeah, it needs to involve a bit of memory allocation, at least memory allocation, if not also freeing. Because yeah, if you also try to do like with freeze, it starts to become really hard for compiler. But yeah, for your own allocator, it should be easy to implement free. But yeah, for a compiler, it's easier to just do malloc and yeah, only malloc, even though it's not efficient. But yeah, I mean, you have two ways to approach this problem, I guess. Experiment a bit more with it, custom allocator or some sort of expression compiler. And yeah, I mean, in general, more C. Like, that's the only way to do it. At some point, it's gonna click for you, and it's gonna be oh yeah, it makes sense. Yeah, but that's what made sense for me, like thinking about pointers as numbers, and when you dereference them, it's just as indices in an array. So yeah, hopefully at least someone had the same, let's say, experience as me, and understood better what pointers are just by thinking of them as indices. So yeah, I guess that's all for this one, and yeah, don't forget to comment if you got it. But yeah, hopefully, I mean, it will be 0 comments and I'll be, oh shit, no one got it. That's funny. But yeah, hopefully you got a better understanding of it, at least a little bit, like 1%. So yeah, we'll see in the next one. So see you.